What's up, guys? Welcome back to another video on AA learning. Today our video is gonna be about logs. So just before I end this video, you guys should know some basic exponent rules before we actually get into logs. So I'm just gonna do like a really quick refresher. I've done exponential growth slash decay like in the last video. You guys can review that if it helps. But I'm just gonna go over a quick refresher of exponents right here, really quick for logs. So in exponents, you guys should know, like, I'm just gonna give you an example of an exponent. 2 to the power of 3, and we know that equals 8. So I'm gonna explain all the parts here. So in exponents, this 2 right here, or whatever that main number I would say is, that's referred to as the base. So that's our base in the exponent. And then this in exponent form. So and then this 3 right here refers to the power. So how we got 8 in this equation is we're basically just doing 2 and we're doing that 3 times. So 2, we're multiplying it 3 times. 2 times 2 times 2. And we know that equals 8. Again, I give you guys another example. Like let's use not 2, let's use 4 to the power of 3 this time. So in this case, 4 would be considered our base as we had labeled here before. And then the 3 again is the power. It's not always going to be 3, but it just turned out this situation. And then we can solve this by doing 4 times 4 times 4. And we know that's equal to 64. So that's just like a really quick refresher on exponents. So now let's get to how they relate with logarithms. Okay, so I'm gonna go over the form again. So we know exponent is usually written with variables. It's written as b to the power of x is equal to y. Just like take that 2 to the power of 3 equals to the 8 example. B is the base, x is the power, y is our answer. So in logarithms, we're gonna have log, and then our base is going to be usually like a bit written a little under our log, not exactly on like the same line. And then our answer, I'm just going to write answer in short, and then is equal to power. Okay, so what does this mean? Okay, so remember, I'm going to bring that example back again. So 2 to the power of 3 is equal to 8. We said this is the base. We said 3 is the power. I'm just going to write B for short and P here for short. We said this is our answer. So in logarithms, what we do is we take this like 2 that we have in the exponent, and that would go as our base right here. And then we would take the answer, our 8 in this case, and it would go right here. And then the power would actually be our answer. So the like variable form with variables would be written like this: log base b of y is equal to x. So we can just again compare these two equations we have here. The base and base match up here. The answer matches up with right here of the log, this part of the logarithm, and then the power matches up with the answer for the logarithm. So this is going to be like how we usually solve logs. And just as a quick heads up, when you get logarithm is something that's going to be on your calculator as well. So in the base, if it's written as log, I'm just going to write example of 25 or something random. If there's nothing in like this area right here, then we're just going to think of it as it's going to have a base 10. But let's say if it was log and then base 5 of 25, then we're inferring, okay, so there's a base 5 is the base. In this case, if there's nothing written down, then we're just inferring that there's a 10 right here. Okay, so let's get into some practice. Okay, so I'm gonna give the example 2 to the power of 4. So first, let's solve for that. We know 2 to the power of 4 is just 2 multiplied 4 times 2 times 2 times 2 times 2. And we know that's just 16. So how would we write this in logarithms? So what we would do is first write our log, and then we need to find what our base is. So remember, our base in exponents is this 2, so that means that's where our log will be 2. So we write a 2 right there. And then what do we get as our answer? We got 16 as the answer. So usually I like to do parentheses just to like emphasize it more. So 16, and that's equal to the power 4. So that's how we'd write the logarithm form of this exponent. So it's basically like inversed almost. And we can do another example for you guys. So 3 to the power of 4. So that's just equal to 3 times 3 times 3 times 3. So 3 multiplied 4 times. So we know that is simply equal to 81. So now let's convert that into logs. So log, again, 3 is the base. So 3 would go down here. And our answer was 81. So 81 would be right here. And then our power was equal to 4. So that's how we write it in logs. So another, so if you guys need practice, by the way, with this, I have, as usual, the review sheet that I'll link in the comments. So yeah, I'm gonna go into now properties of log, because this was like the more like easier part of it, I would say. But properties of log is also gonna be important for knowing logarithms. So let's create a new sheet here. Okay, so I'm gonna label this properties of logs. Okay, so we have here 5 properties. There's another property that uses natural log. I can get into natural log in another separate video. This I'm just using just logarithms, not natural log. Okay, so our first property is going to be the product property. Okay, so what we do in the product property, I'm gonna write in the variable form. So it's log base, and I'm gonna just base is b, m times n is equal to log base m plus log base n. Okay, so what does this mean? So basically what we're doing here is we're like separating the log terms, so and then adding them instead of just taking it as one whole log. When we usually do this is like with larger values in the inside to like help break it down and make it more smoother. And then in some cases, if you're given like a long like log equation to solve, your teacher may say like condense it or expand it. In that case, this is the condensed form, and this is the condensed form, and this is the expanded form. So you guys have to remember, just like think expanded, okay, that's the longer one, so we have to like add the addition and make it longer and everything. But if we want the condensed form, we just want it smaller, so that's just m times n. So let me give you guys an example. So over here, we have log base 2 of 8 plus, oh, that's a terrible plus sign, log base 2 of 4. As we can see, these two are very simple logarithms we can solve. So 2 to the power of what is equal to 8, and then 2 to the power of what is equal to 4. So here we know that what is 3, and we know this here is 2. So if we just add those together, that gives us 5 as our answer. Another way we could have wrote this would be instead log base 2 of 32. Because what we can do is multiply this 8 right here by this 4, and that'll give us 32. And we still get 5 as our answer, because 2 to the power of 5, that's just equal to 2 times 2 times 2 times 2 times 2, which gives us 32 right here. And that's 5 2's. Okay, so that's the product property. So now I need more space, so I'm going to do another sheet. Let's do the quotient property. Quotient property. Okay, so what this property says, I'm going to do again variables. Log base, or b, of m divided by n is equal to log base b of m minus log base b of n. Okay, this is kind of like the opposite of the product property, because when we multiplied it, we add. When we divided, we subtracted. So I feel like this one's straightforward because we learned the product property. So I'm just going to give another example here. Let's say we have log of 5 of 125 over 5. What we can do is we can rewrite this. Again, remember, if we want to expand it, this would be the expanded form. If we want to condense it, this would be the condensed form. Okay, so going back to this example right here. So log base 5 of 125 divided by 5. So remember, our base is b. So in this case, it's 5. So log base 5 and then of m. So m is going to be the top part. So that's 125. And let's do parentheses to make it more clear. Minus log base is still 5. And then the n value right here is 5. So now we broke it up to solve a simpler logarithm that we could solve. So 5 to the power of what is equal to 125? And we know that's 3 because 5 multiplied 3 times gives us 125. And then 5 to the power of what is 5. So that's just 1. So our answer for this question would be 2. So that's the quotient property. And let's move on to the next one. So our next one here will be the power property. Okay, so this one I would say is a little more tricky. It's more different compared to the other two that we did. So I'm gonna do variables again. Log base, and that's gonna be b, of m to the power of k. So that is equal to k log b of m. So basically all we're doing is taking this exponent and moving it here to the front. So I think this one is clear with the example. Let's do log base 3 of 27 squared. Okay, so at first glance this seems like really hard to do. 27 squared, that's a huge number, no? And doing a log base 3 of that. So what we would do is we would move that 2 to the front. So we would just place that 2 here. And now we can treat this as two separate terms basically. So log base 3 of 27. That 2 is still there. So remember, 2 multiplied by the log base 3 of 27. Log base 3 of 27 is just 3 times 3 times 3. That's equal to 27. So how many 3's are there? There's 3 3's. So 2 times 3, the answer would be 6. So this is actually really helpful if you guys want to, like, if you see a crazy like log and you need to simplify it, you guys can use this way. Okay, we have 2 more log properties, and then I'm gonna do some like really quick practice with you guys, and yeah. Okay. So our next log property is the 0 property. These next two, this one and the last one, is gonna be, I feel like, the easier ones. These you guys kind of saw it already in the past ones we've done. So what this one says is log base b of 1 is equal to 0. And that makes sense. So I'm just going to give an example again because this one's clear with the example. Log base 7, we'll say for this one, of 1 is equal to 0. Now if we write that in exponent form, remember this is the base, this is the answer, and this is the x power. So 7 and 0 is the power is equal to 1. If you guys know about exponents, anything raised to the power of 0 is always 1. So yeah, that one was pretty straightforward. Okay, let's go to the last log property here. Okay, so this one's called identity property. So what this one says, again, variable form, is log base b of b is equal to 1. So what this means is b, I'm going to turn to exponents here. B to the power of 1 is equal to b. And that makes sense again. Let's use an example here. Log base 4 of 4 equals 1. Remember, what this is saying is 4 to the power of 1 is equal to 4. And that's clearly true. We can see that. So those are the main log properties you guys need to know. So let's just do some quick practice problems I have here. You guys can pause the video while I'm doing that or just watch me solve them. And then again, there'll be a link to Google Doc with practice questions. Okay, so log base 5 of 125. This one is pretty simple. 5 times 5 times 5. There's 3 5s. Answer's 3. Another simple one here. Log base 4 of 64. 4 times 4 times 4 gives us 64. If you guys are ever confused, we can be like, okay, 4 to the power of what will give me 64? And you guys can think through like this. So the answer here is also 3. And our last example here would be log base 2 of 64 squared. Alright, remember, this looks tricky at first, but think of this as that value you have to bring down. We want to bring this exponent down. So it'd be 2 log 2 of 64. 2 to the power of what is 64? Well, we know 2 to the power of 5 is 32, so 2 to the power of 6 would be 64, because 32 times 2 is 64. So 2 times 6, and our final answer is 12. Alright, thank you guys for watching. Remember, practice problems in the comments. Yeah, thank you guys so much.